Hello geology students. In this video blog I'm going to talk about mineral identification. So this is for our first identification lab, the mineral identification lab for Geology Online. So if you haven't already, open up your big huge lab kit and we're going to go through and start to talk about what you need to do for this lab. And if you look through, you're going to find a couple extra things. You're going to need to have the hand lens out. There's a little white tile. This is called your streak plate. And then you also need to have your little glass plate. Hopefully you guys can see that. That should be somewhere in the box. That's just a regular piece of glass. It's not a sample. Okay, now the next thing when you look at the lab kit, I'll kind of do that. Hopefully you'll see that there's a lot of different things. When we start over on this side, I have all of my minerals. Then we have some igneous rocks. We have sedimentary rocks. We have metamorphic rocks. And the last few things in a lot of the vials, these are actually all fossil samples. And so they're all numbered. There is a list that comes with each lab kit. And if you don't have yours in your lab kit, you can download a copy of that from our Blackboard course. But when you're doing the identifications, all you need is the lab paper itself and then the mineral samples or the igneous rock samples for whichever lab. It's actually better if you take that sample list and you put it aside until you're done. The goal for these labs is to understand how the different samples are how you tell them apart, what geologists do to tell them apart, and then just start learning some of the basics. I'm not as worried if you get things correct or incorrect. I will make marks of things, but when I grade labs, I take fractions of points off because for me the process in a lab is to go through the assignment. I want you to try to do it. I want you to do it yourself. I don't want you just to say, hey, oh, sample 1 is this, and then write it down and then try to backfill it in because you won't actually learn what the properties are for minerals in this case. So then the first thing that you'll do is you'll pull all the mineral samples out. So those are samples 1 through 15, and you're going to set them aside. I actually set them onto the big, huge piece of foam material, so you can take all those out of your box. Try to get all of them. Okay, and some of them are very fragile. Okay, and so then you can see I've emptied out the tray. You can set that aside. And now what I've done instead is I've put them on top of the foam pad so you can see that. I'm going to try to do this so you can see mostly the samples. So again, I have the hand lens, the streak plate, and then all the samples. When we're identifying minerals, the first thing that we look at is to figure out if we have samples that are metallic or non-metallic. Okay, metallics are things that look like metals. So they look like steel, they look like gold, they look like silver or brass. These things can be shiny or they can dull. Remember, like a steel pipe could be very dull, but you know it looks like a metal. So you really have to decide if it is metallic or non-metallic. And remember, non-metallic things can be shiny like glass, okay, but they're still non-metallic. It does not look like metal, okay? So we're going to take some of the things that we think are metallic and we're going to set them aside. So I'll do that quickly. I have lots of experience with these, so it goes pretty quickly. Okay, so the next thing, whoops, rolling around. Next thing you'll see, so I have the samples set up. I've got metallic minerals, and then I have non-metallic minerals. And then just as a key, some of these non-metallic minerals are going to be dark in color. Okay, and then you're going to go through and you're going to just start working on one group of those minerals. So I would start out by looking at the metallic minerals. Okay, these are all those ones that look like metals. Okay, and the key for metallic minerals is the streak plate. So this is going to be a big part of how you figure out what these minerals are. And you're going to do a streak test. So the way you do a streak test is you hold the plate in your hand like this, and you pick up your sample. In this case, I have sample number 4, and you're just going to trace it across the tile. And you're going to take a look and decide, whoops, what color that is. Okay, so what color is that streak? And you'll find that different minerals, let's see, going to do a couple up here for you. And there we go. So if you look carefully, I'm trying to get it centered on the video camera, the streaks are different colors. So even though these samples, in this case, 2 of them look different, but 2 of the samples are both dark gray in color, okay? And whoops, one of them has a reddish brown, this one on this side, has a reddish brown streak. So that will be one of the key identifying factors to go through that. Okay, and then you'll just have fun looking at the different samples. For your non-metallic minerals, I'm not going to go through everything because the lab will walk you through each part, but you will want to identify, is it metallic or non-metallic? What is the streak? The luster for metallic, you can say it's metallic or non-metallic, but you can also write if it's shiny or dull. When we look at our non-metallic minerals, the luster, it's going to be non-metallic, but then you can say it looks vitreous or like glass. Maybe it's dull, okay, or pearly. Some of them have like a pearly look to them. So it's really, luster is the way light reflects off the mineral sample. So if it looks like a metal or a non-metal, and then we have some designations for the non-metallic minerals if they look pearly or glassy or dull. And you can read through that in the lab. Okay, let's see. Another property that you're going to want to do, pay attention to, is looking at the hardness of your samples. So the glass plate has a hardness of about 5, and if your sample can scratch the glass plate, it means it's harder than 5, and if it cannot scratch the glass, it means it's softer than a 5. Your fingernails have a hardness of 2, so if you can take some of the samples and you can scratch them with your fingernail, they're very soft. Some of the metallic minerals will be very soft, and you're going to need to try to work out the hardness to best that you can. You're going to want to take a penny and have a penny out, because a penny can be used to try to, you can try to scratch pennies. If it's softer than the glass, harder than your fingernail, then you want to see if you can scratch the surface of a penny with the sample, and that will tell you it has a hardness greater than 3 but less than the 5. And then you'll go through, maybe you have hopefully a toolkit somewhere, and you can get out a nail that you would normally put in your wall, and you can use that. That has a hardness of about 6.5 to try to figure out how hard those samples are going to be. And so that will help you determine the hardness. And you do want to do more than just greater than or less than 5. You actually want to try to get it within a window, because some samples will really start to look very similar, especially in your non-metallics, and that hardness can be a key to try to tell them apart. Additionally, if you get down to 2 samples that you can't really tell apart, but you look in your descriptions and one is harder than the other, you can try to figure out if one sample scratches the other, and that will tell you which one is harder. Okay, another trait, feature that we look at in samples, mineral samples, is to try to figure out if the sample has what's called cleavage, and that means it has a plane of weakness based on the bonding within the mineral sample that causes it to break into planes. Okay, so a cleavage plane is what we're talking about. And in cleavage, we're talking about the number of these planes that we see, as well as the angles. So if there's 2 cleavage planes, we want to figure out if it makes a 90-degree angle or if it's something that is not 90. So maybe it's bigger or smaller than 90 degrees. So just a quick look. This is a sample 12. If we look at it, it's very thin. A lot of students think this is a little piece of glass that they're looking at, but this is actually a sample that has 1 plane of cleavage. And when I talk about its plane of weakness, I could actually peel off, so you can kind of see that it peels off layers. So it's a little bit like cellophane, but this is actually a mineral sample. So if I really wanted, I'll pull one off the back side to show you that it cleaves perfectly with 1 plane. So I've taken it apart. Okay, and so that's still a piece of the mineral. It's just thinner now. Okay. So that's 1 plane of cleavage. Other samples can have 2 planes of cleavage. You'll need to look closely to figure out, this, let's see if I can hold it up. So this is sample number 5. So this flat surface on the top and the flat surface on the bottom, that's actually showing us a plane of cleavage. If you look carefully within the sample, you might see planes that are actually breaking in the sample, and that will tell you that there's some more in there. And then as well, this one actually has a secondary plane. If we turn it over on the side, so these 2 sides come together. So we would want to look at the angle at which those 2 come together. Okay, you'll see It's actually not at 90, so that's a key for that one. Other samples, when you look at them, they'll look very cubic, okay? And so this one has 3 planes of cleavage that are all meeting at 90 degrees, okay? Now, on the non-metallics, it's really helpful if you can look inside the sample because you'll be able to see some of those. If you're planning to keep your lab kit and you want to really play with it, you could take a small hammer and start banging at the corner of some of the samples. If you were to take, I always get it confused if this is sample 9 or sample 6. If you have a non-metallic one that looks like a 9 or a 6, you could kind of bang on a corner and you'll see it starts to break in perfect little cubes. So that one has 3 planes of cleavage at 90 degrees. Okay, another one that to take a look at for 3 planes of cleavage at 90 degrees would be sample number 3, this one. If you look at it closely, let me try to bring it up here. We can get it in focus. You can't probably see that. Well, it's this one edge that I have right here actually has some nice places where I can see little cubes that have been broken out. And again, if I smash this with a hammer, it will break into perfect little cubes. Additionally, this one feels very heavy. Okay, this sample is one that has a very high specific gravity. So if you have samples that are about the same size and you hold them, these are all roughly the same size, one of them will probably feel pretty heavy. Okay, that sample. Number 3 has a very high specific gravity, and so you can use that as an identifying feature, especially if you were to compare it to sample number 4, which has a very low specific gravity or density. Okay, that should be enough to really get you through part of this lab. The last thing that I want to point out is that when we're looking at our nonmetallic dark minerals, you will have to take a look, sometimes trying to figure out if it's splintery or not, or blocky is a key for those. And then sample number 13 may cause a little bit of challenge. Part of the key on this one is going to be color, but note that this is actually an aggregate of lots of the same mineral. So it's little tiny pieces. It's massive is what we would say for its crystal form in this case. We're not actually seeing pretty crystals. But we're looking at a very massive sample, and so you'll have to just use your best. Definitely use the hand lens so you can take a closer look at things. This will certainly come into play when you're trying to see some of the cleavage on things, as well as later on when we're looking at igneous rocks next week and sedimentary rocks. This hand lens will come into a lot of use. So I hope that helps you get started with the lab. If you have any questions, please contact me.